Hi everyone, welcome back to our new video on AWS Network Firewall. And before I begin, I would like to wish everyone and all of my viewers a very happy and prosperous New Year 2024. In this video, we're going to talk about what AWS Network Firewall is. We'll talk about what are its components like firewall policies, role groups. When we'll talk about role groups, we'll also differentiate between stateful and stateless role groups. We'll talk about what all the actions which you can define, which your AWS Network Firewall can take on the behalf of your role groups. Then we'll also talk about the network flow when you introduce your network firewall into your VPC. We will also talk about the architecture which we're gonna use to demonstrate the use case of AWS Network Firewall in your VPC. So let's begin, guys. So basically what AWS Network Firewall is, it's a highly scalable, highly available, and a managed network firewall. So it's very important to understand it's a managed service which is highly available. When we talk about availability, it gives you 99.99% availability. 4 nines is the availability which AWS promises. It's highly scalable. It can automatically scale based on the kind of a network traffic your workloads are receiving. It can provide you up to 45 Gbps of a kind of a network connectivity, and you need not to worry about the provisioning a capacity or load balancing it, right, which we normally do when we have a security infrastructure to manage, right. Now the question comes what it does which other security controls do not, and why do we need a network firewall. Basically we have security groups, we have a web application firewall. If you do not know about web application firewall, we have a very good video, a recent video which we spoke about at length, and we demonstrated it an application load balancer along with the web application firewall. So when we talk about your security groups, like those are the foundational firewall controls on AWS. We usually, use them as a kind of a very first control which we put in place when we spin up any kind of workloads in our environment, right? And this, those security groups will give you access to and from your EC2 instances based on what we call a 5-tuple information, right? Which basically is source and destination IP, source and destination port, and protocol. Now, other than that, the web application firewall is basically for your specialized web application use cases, which works on layer 7 of OSI model, while your AWS network firewall will work from layer 3 to layer 7 of OSI model. That's why it gives you blanket protection for your VPC by protecting any application type on any port or which is using any valid protocol. So that's the use of your AWS network firewall, which differentiates it from security groups and the web application firewall. So if you look at the security group, they only protects your EC2 instances in a specific subnet. If you talk about web application firewall, that is for specialized web application use cases, works at OSI layer 7, while this one works at from layer 3 to layer 7 of OSI model, right? So this is the use case where you would like to use AWS network firewall. Now what all it inspects, what all it can do for you, right? So it can inspect the traffic which is coming from internet to your VPC. It will also, or it can also inspect the traffic which goes out from your VPC to the internet. You can also put a network firewall between a VPC to VPC traffic. You have a SaaS kind of a scenario. It will also be able to inspect the traffic which comes through AWS Direct Connect and your site-to-site VPNs as well. So these are the use cases where you would like to, or the inspection points where your AWS network firewall can help you to inspect the network traffic. Now, as I said, it is fully integrated with your existing security tools. So it uses an open source IPS system, that is intrusion prevention system, Surikata, for stateful inspection. So what is the use of that? If you are already using something based on the similar format of Surikata, you can keep on using the same rules. You need not to change the format of those rules. So this network firewall can easily be integrated into your existing security tool setup as well. Now let's talk about AWS firewall, network firewalls component. The first component basically is a firewall policy. The firewall policy would contain stateful and stateless rule groups along with some firewall behavior related policy settings, right? So this is what the first component would be. So you'll create rule groups. That rule groups will be contained in a firewall policy along with those firewall behavioral policy settings. Now what happens, that firewall policy basically would be using these reusable set of stateless and stateful rule groups along with these policy level behavior settings to provide network traffic filtering behavior, right? Now what next, we have the final component that is called firewall, which will basically connect these inspection rules in the firewall policy and will take these rules and these policy settings and protect your VPC workloads in the backend, right? Other than that, when you define your firewall, you can also log the traffic. You can define where the traffic alerts would be logged. You can use you can define logging of alerts or logging of your traffic flow. So all these settings you will define at firewall level. So there are multiple settings. See, at rule groups you will define rules which will provide the conditions, and then rule groups will be collection of those rules and will decide what happens at the end of the inspection criteria based on the rule groups and their actions. Firewall policy will take those rule groups plus some additional policy settings and provide a whole architecture which will be connected with the help of a firewall to protect your VPC. So this is how it works basically, right? Now moving forward, so let's quickly give you what rule groups are. So as we spoke about, we have stateless rule groups and the stateful rule groups. Stateless rule groups are basically where your inspection happens in isolation, right? So our stateless rule groups will evaluate those packets in isolation without any further context, right? It will not it will just define those standard network connection attributes like ports, protocols, like all that 5 tuple kind of a scenario, right? To examine a packet on its own. I mean, every individual packet is inspected irrespective of its context, right? Or the direction of the traffic. While your stateful rule group, with the help of Surikata rule engine, will evaluate the traffic in the context of the traffic flow, whether it's incoming traffic or outgoing traffic, that will be considered while inspecting the traffic with the help of a stateful rule group. Sorry. Now you can use Surikata compatible format while you're writing your rule groups, and management console provides you a kind of a web form to do that along with the entry of the basic rules as well, right? So this is basically your rule groups are. Now what are the actions network firewall can take based on the configuration? So for the stateless rule group, the actions are pass, drop, and forward to stateful rule. So basically it's simple. If there is a match found and the configuration says okay, if the match found pass the traffic, then the traffic is no longer inspected further and the packet is permitted to go to its intended destination. If there is a match found and the configuration says drop the matching traffic, then the packet is dropped and it's not allowed to go to its intended destination. And if the third rule, which is basically says if you inspect it and send it to the stateful rules engine as well for the further inspection, then your stateless engine will discontinue the inspection of the packet and forward it to the stateful rule engine for the inspection. So this is basically the actions which defines what happens to the traffic which hits the traffic AWS network firewall. Now for stateful rule group, what are the actions which we can have? Here the action will depend what kind of a rule type you have. So we have got 3 rule types where action for standard rules and the Surikata compatible string rules remain same, and there's a different action which we can have on domain list kind of a rule group or the rule type. Sorry, all the domain list comes into the stateful rule group only. So for standard rules, you have pass, drop or alert, and reject. So you can say PRDA or PDRA. So that's where you can use it or try to remember it. So for the pass, firewall has to discontinue the inspection of the matching packet and permit it to go to the intended destination if it finds a match, and the action says pass it. Another thing, rules with the pass actions are evaluated on the very first. I mean, they are given priority while evaluating, so they are evaluated before rules with other action settings of drop, alert, or reject. If there is a match for a drop or alert, then the packet gets evaluated against all the rules with those drop or alert settings, and accordingly action is taken. For the reject, there's a bit of change. It's similar to drop, but other than dropping, your firewall engine will send a reset packet back to the sender of the packet, so that the sender can understand, okay, my traffic has been discontinued or dropped, I need to reinitiate the traffic again. There's one thing, your reject is available only for the TCP traffic, and it will not support your FTP and IMAP protocols, so it's only for the TCP traffic. In case of a domain list rule type, you will have allow. Basically the allow will act as a kind of a, you know, a domain name list which is allowed to be accessed, right, for the specified protocol, and the protocols are HTTP and HTTPS, and we'll speak about it when we log into the management console. And for the deny, basically, if you put a list of domains which and state the action as deny, then the traffic to those domain which is listed in the settings will be denied or the dropped. It will not be allowed to go to the intended domains. So this is basically the rule group action which we have. Now let's quickly talk about the how the traffic flow happens when you introduce the network firewall. So basically, if you look at it, when you this firewall subnet will contain your firewall endpoint, and this is my workload subnet. So once your traffic hits the internet gateway will have a routing enabled which says whatever traffic comes in for this VPC sent to this VPC endpoint, that is your firewall subnet endpoint. And once the subnet hits the traffic, it would be inspected through stateless and the stateful rule engine based on the configuration which you have configured. So let's say first your stateless rule engine inspects the traffic against stateless rules, and if finds it's no match, or the action says if no match, drops it. So if it is a traffic which has to be dropped, the traffic is dropped, and if it is a match, traffic is passed, or based on the configuration also it can be forwarded to the stateful rule. Once it hits your stateful engine, then the traffic gets inspected against stateful rules, and based on the configuration, either the traffic is dropped, passed, or sent an alert into the logs as well. And how this traffic moves, it basically moves based on the routing which is defined here at different levels. We have a routing defined at the gateway level, we have a routing defined for firewall subnet, and as well as for the customer subnet. For firewall subnet, it says okay, if there's, I mean, for the outgoing traffic, if there is a traffic which has to go to the internet gateway, I mean to internet, it firewall subnet sends it to the internet gateway, or your workload sends it to the firewall. So this is how basically happens. So while coming back, while incoming traffic, internet gateway, firewall subnet, and the customer subnet, and outgoing traffic from the customer subnet through the firewall reaches to the internet gateway. So that's how the traffic direction or the traffic gets inspected through firewall. Now let's talk about the architecture which we're going to use. So we're going to create a single VPC with with the one web server. We'll put normal routing where local traffic stays local VPC, if the destination is VPC, and if it is a internet based, or if it is internet related traffic, it reaches to the internet gateway, and from there it goes out to the internet. We will create this first, and then we'll introduce the network firewall into it. Once we introduce the network firewall, we'll create one more subnet. We'll create a firewall subnet. We'll change the routing based as you see on the screen, and we'll test that the traffic should not be able to reach to those domains which we are going to decide. So basically what we're going to see, we're going to do an RDP based rule, an ICMP based rule, as well as a domain list based. So we'll try out these. We'll try one stateless and one stateful rule in our demonstration, which you can follow step by step. So let's begin the demonstration. Let's log into the management console. Guys, before we move to the management console, let's follow through the steps which we're gonna perform in our demo so that you can follow along. So we'll create a VPC with 10.0.0.0/16 as the CIDR with the name firewall lab. We'll create a workload subnet which would be publicly accessible subnet because it's gonna contain our web server, which is going to be an EC2 instance. Then we'll create a security group to allow RDP, HTTP, HTTPS, and ICMP traffic. We'll create and attach an internet gateway to our VPC for the traffic to go to internet and to come from the internet. Then we'll create a route table so that the internet traffic can be sent to internet gateway. EC2 web server will launch and we'll install IIS and we'll check a few sites whether they are accessible or not. This is what we're going to do. Then we'll create our firewall subnet with the CIDR. We're going to keep it CIDR/28 because it needs very few IP addresses and it will not contain any other workload, the application servers, just the firewall endpoint. Then we'll create a stateful rule group, which is basically going to be a domain list type of a rule group to block traffic to a few sites. We can also use the same list of sites to allow the traffic as well. Then we will use we'll also create a stateless rule group for ICMP and RDP traffic. Then we'll change the routing and we'll put these rule groups into firewall policies, and we'll also create a firewall to connect all these firewall policies and these reusable rule groups. And then we'll change the routing so that the traffic can move through the firewall subnet now, and then we'll check the functionality of it. So that's how we're gonna use it. So let's jump into the AWS management console and start configuring things. So here we are into the management console. So let's quickly create the VPC first. I'm going to find VPC. Those who do not know how to create a VPC and what VPC is, we have got a detailed deep dive video on VPC which you can see. I'll also put the link into the description below. So here you can click on, this is your VPC dashboard. You can click on your VPC or you can use the wizard. So here you will see there's only default VPC is already there, which we are not going to use. We're gonna create our own VPC. Click on create VPC. So you can use the wizard here by clicking VPC and more, which will create everything, which is the preview of the same is being shown here. All these things will get created. I don't want to do that. I'm gonna create it manually. So I'm gonna call it firewall lab VPC. Going to be have manual input, not the IPAM. So this is going to be my CIDR. No IP version 6, tenancy default, tags the one which I have used on above, create VPC. So it's going to create the VPC. VPC has been created. The next step would be to create the subnet. So click on subnets. You will find default subnets will already be there. We're going to create our own. So click on create subnet. This is the VPC which you're going to select, firewall lab VPC. Give it a name. I'm going to call it workload subnet public. Select the availability zone as 1A. This is my VPC CIDR block. For the subnet, I'm going to use 10.0.0.2.0/24, and that's it. Click on create subnet. Now the subnet has been created. The next thing is to create an internet gateway. This is a default one which I'm not going to use. Click on create internet gateway. Name it, let's say firewall IGW01, and click on internet gateway. So it is created. Now once it is created, you need to attach it to the VPC before it can work. Currently state is detached, so click on attach to VPC here, or you can pick it from here. Attach to a VPC, select your VPC. Only the firewall lab VPC was available in the drop down because this was without internet gateway. Click on attach internet gateway. Once it is done, it shows start showing state attached, but this will not be sufficient. You need to change the routing as well before the traffic can start flowing through the internet gateway. So these are the default route tables. I'm gonna make it, I'll call it firewall public route table. This is the main route table. So what I'm going to do is I'm going to associate this route table with the workload subnet by clicking at subnet association. Click on edit subnet association, select the workload and save your association. Now this route table has been associated with the workload subnet, which is publicly accessible. But again, we have not changed the routing yet. So let's put some routing. Click on routes. Click on edit routes. Currently it has only the route for the local VPC. This is the VPC CIDR. I'm going to add the route. I want this 0.0./0. So this is the traffic which is intended for the internet. I want that this traffic should reach to the internet gateway, and this is my internet gateway, right? So this we just created and attached our VPC. Click on save changes, right? So now the routing has been done, subnet has been created. Now let's go and create our first EC2 instance. which is going to be in a Windows IS machine. So I'm gonna go AWS. Let's go back to the home page, and let's ECT is already there, so you can either find it from the search console, or you can click here if it is already showing on the recently which visited ones. Currently we have nothing, right? Click on launch instance. Give it a name. I'm gonna call it web firewall demo EC2. I'm gonna use Windows machine. I'm gonna use 2016 base, which is again a free tier eligible. So guys, if you don't want to incur any cost on this following this demo, please make sure that you are selecting options which are free tier eligible. So I'm going to use 2016 base. Here I can use T2 micro, so let's stick to the T2 micro, although it is going to be very slow. So once you do it at your in your account, if it is for testing purposes, you can use T2 micro. I'm going to use T2 medium because that will be give me a bit of performance, will not hang on everything when we start configuring a web server. I already have a key pair. I'm going to use this one, otherwise you can create a new one as well. So this is the key pair. Now I'm going to add it the network setting because I don't want this EC2 instance to be launched on default VPC. I'm going to make it firewall lab VPC subnet. I'm going to use workload subnet public. I want this to have a public IP because this is going to be publicly accessible web server. I'm going to create a security group. I'm going to call it firewall demo security group 01, and I'm going to just copy paste the same thing. You can put descriptions on something which is meaningful. So the first is RDP, and it is allowed anywhere, although it is not suggested for the production workloads. So you have to be careful what you put as a source here. I'm going to add more rules. I'm going to add for HTTP. Again, I'm going to make it so it's from anywhere allowed. Then because I'm going to delete this security group as well as all these resources immediately, so I can live with this choice. Otherwise for you, you have to be very careful which sources you are going to allow into your EC2 instance. Other than that, I'm going to use HTTP and ICMP because we will check the ping we'll also check the pinging the instance. The one more, this is going to be anywhere. I'm going to put one more for HTTPS. So here is the HTTPS, again from anywhere, and that's it. So I'm not going to change the storage and all. I just click on launch instance. It will take some time before the instance is ready. Once it is ready, we'll come back. Now you can see the server is up and running. It has passed both of the checks, so we're just going to connect to it so that we can install the IAS and check the functionality of it. Click on connect, go to RDP client, and you can download the remote desktop file. First we'll get the password. Click on get password, upload the private key file which we just used. So decrypt your password. Now copy the password and keep it safe somewhere, which you're gonna use multiple times. So click on download remote desktop file, or you can use MSTSC client and you can use that public IP to do the RDP part. So I'll connect to the Windows machine and then I'll come back again. Now as you can see, we have logged into the EC2 instance. So I'm going to install web IS feature on this one. So I'm going to open PowerShell. So this is the command to include install Windows feature, that is as web server. So I'm going to run that command to install IS. Now you can see the IS is ready. So we have installed IS. I have done certain changes. Now if you open the browser here, you can see this is my web page, static web page. If you click on that, it takes you to the network firewall demonstration page. We also check a few of the sites. Let's say if we are able to open aws.amazon.com, it should work now because currently there's no firewall and it's able to reach to this intended destination. So this is working. So let's see if Google works here. .com, so it's working. Great. Let's msn.com. It's working. Great. So you can see all these sites are working, right? So now what we intend to do, we will go and create firewall rules, rule groups, and then we'll put them into the firewall policy, and we'll use domain list to allow certain websites and to block certain websites, right? So let's go and do that. So let's go back to the AWS management console. So now we are at our AWS management console. So to create all these things, we need to go to VPC again. So again, go and find VPC from here, VPC. As I said, first we need to create the firewall subnet. So where the this endpoint would be created. So let's quickly create that. It's running a bit slow, it looks like. So if I click on subnet, should quickly come up. So click on create subnet. So we will create that subnet again in the firewall lab VPC. I'm going to name it firewall subnet, right? I'm going to keep it at 1A, and I'm going to use the CIDR 10.0.4.0/28. Click on create subnet. So it's gonna create my subnet. So that's the one thing which we have done now. Now if you just scroll on your left hand side on the VPC dashboard, you will see here the network firewall. So you will have options to create firewall policies, and network firewall rule groups. So first we'll start from the network firewall rule groups. It's taking a bit time to load, I don't know why. Okay, so click on again, when we create rule groups, one thing which we need to understand, which I have not spoken about it yet, your rule groups can be AWS managed rule groups, which is here, or it can be your own managed rule groups which you create. So these are the certain rule groups which you can use. They are ready to consume. It will tell you what is the name, what is the description, what it does, what is the capacity, and what is the rule order. We'll talk about the rule order and everything pretty quickly. Here what happens, if there's an update to the rule groups, it will happen of its own. You need not to worry about the maintenance and the management of these rule groups. AWS takes care of it, and most of these are free to use, right? So you can use these or you can create your own. So in this demonstration, we're going to create our own. Click on create rule group, and we're going to create a stateful rule group first. So it's a stateful rule group. I'm going to call it domain list rule group. Once you pick your rule group format, you need to decide the rule evaluation order. So whether you want there that your rule should be evaluated in strictly the order which you recommend, which is basically the recommended method as well. But there is another one which used to be the default order earlier, where rules with a pass action are processed first, the one which we talked about earlier in the presentation part. So I'm going to pick on action order. So where I want that pass action are processed first, followed by drop, reject, and the alert actions. Click on next. Give it a name. I'm going to call it stateful domain rule group 01. You can give a meaningful description to it, which can tell the purpose of the rule group. Capacity is basically the number of rules which you can expect to have in this rule group during this lifetime. So basically this number exactly is not the capacity. This capacity depends upon the options or the configuration choices you have, right? Like TCP or UDP, or how many IP addresses or IP range you're going to use. So accordingly, the capacity will be utilized. So based on this capacity, your resources will be allocated for your network firewall. So be careful that you cannot change it later, right? So it's basically you give it some room so that in case tomorrow you need to increase the rules into this rule group, it should be able to accommodate or should be able to take care of that capacity as well. I'm going to keep it at 1000. You can have it from 1 to 30,000. I think 1,000 is good enough. So click on, so here we need to put the domain names. I'm going to put the domain names here. Let's say I want to use google.com and www.amazon.com, and let's say www.msn.com. Now I want to use these three sites or the domains. I'm going to use a default CID range. Default CID range is basically it's a source traffic from where you are from the traffic which is going to originated from. If you pick default, then the source would be the CIDR of your VPC, and if you want custom, you can use the custom. You can put your own CIDR ranges, right? You can inspect HTTP and HTTPS protocol both, and the action can be allow or deny. When you use allow action, then traffic to these sites would be allowed, and for any other site would be denied. And if you pick deny here, this list will be used as a denied list, and traffic to these website would be denied, right? Click on next. I'm going to make it allow. You can use customer managed key for the encryption. By default, data is encrypted with an AWS key, but if you want to use your own, you can customize the encryption settings, which we are not going to do for this demonstration. I'm not going to use tags, but it's highly recommended that you use tags here. Click on next. So review your choices here and click on create rule group. So this is my first stateful rule group which I just created. Now let's go back. I want to create one stateless group as well. So this time I'm going to use stateless. Click on rule group name. I'm going to call it stateless ICMP and RDP traffic, which I'm going to allow through this, right? I'm going to use the same as a description. You can put some meaningful description to it. I'm going to use 1000 as a capacity. Click on next. Now you need to define the priority. Rules with the lower priority would be evaluated first, and each rule within a group must have a unique priority setting. If the rule group contains multiple rules, then each rule should have a different priority setting. So I'm going to make it 10, right? Here you can use your protocols. Basically the stateless will work on that 5 tuple thing where you should use protocol, source IP, source port, source destination IP, destination port. So I'm going to remove this all protocols. I'm going to pick ICMP as well as RDP. So if I can search for RDP, so this is RDP, right? So what I'm saying, for these two protocols, ICMP and RDP, let's source any IP version 4 address at any port, destination if it is 10.0.0.0/16, that should be allowed. I want this traffic to pass, right? Again, here are the rule actions for my stateless, which is either pass, drop, or forward to stateful rule groups, right? So either you can allow the traffic to pass, you can drop the traffic, or you can use to send the traffic to the forward to stateful rule groups. I want to use both of the engines, so I'm going to forward this traffic to the stateful rule group, right? If you want to publish any metrics, you can allow here. It can have a custom CloudWatch metric to
Guys,
monitor
now
the
we
usage
have
of your
configured the routing. Now it's time to
rule
check with the
groups.
routing.
So once you are done with the
network
configuration
firewall is
part of your
working
rule
as
groups, click on
intended. So
add
I have
rule.
logged in
So here you can
RDP into my
add the rules. So here you
web
can see the
server.
priority, protocol,
Let's
source,
open
and
the
the destination, right? Click
browser
on next.
and we allowed
Again, if you
google.com.
want
So
to use
let's
the
go
customer managed key for the
google.com. It's
encryption, you can use
working
it,
here.
which we're
Google.com
gonna
is
avoid
working.
this time. Tags we're gonna
So
avoid.
let's go
Click
and
on
try it
all
in
the
a
options, and
different
you
way.
see you can,
Now what
once
I'm
you're
gonna
okay
do
with the
is
settings, you can
I'm
create
gonna
rule
change
group
this
here. So now we have
stateful
created
rules
stateful
site
and
from
stateless
allow
rule
to
groups. Now let's go back
deny.
again.
So
I want to show you
I
one
can
more
go
thing. When
traffic
you
to inspect action, click on
create
edit.
stateful rule
I'll
groups,
just put it as a
you can
deny.
have 3
Save
different
my
type
rule
of rule group
groups.
format.
I'll
One
go
is
back to
standard
my
stateful
RDP
rule,
machine.
and one is domain list, which we use, and then one we have a suricata compatible
So
rule
I'm
string. So
back
if
to
you
my
go
machine.
standard stateful rule, so you'll
So this
have
time I
again
want to
strict
open,
order,
let's say
action order. You
Microsoft.com.
can pick those things. You can put your name, descriptions, let's say anything, because we're not using it. I'm just
See,
going to
it's
show you how you
working.
can, what you can see here. Capacity,
Let's say I
let's say
want to
1000,
use
and if you go here,
example.com.
you will see this IPs. You can put
This is
rule
also working.
variables, or you can
So guys, you
see
can see
use IP
the
set references,
firewall is
which
working
is optional
as
again, and you can use
intended,
standard
right?
stateful rules where
Now
you again it
let's
looks like
go
a more
and
of a stateless
check one
or a
more
five
thing.
tuple kind of a
I
thing where you can
allowed
put your
RDP
choose
and
your protocol,
ICMP
you can
in a
choose your
stateless
source
rule
and
group.
IP
So
addresses,
let's go and see what's
source
the
IP,
threads of there.
destination IP, port and
I'm just
protocol,
quickly gonna go
and you
there.
can define the traffic
There's
direction,
my
whether
rule
it's a
groups,
forward traffic which has to be inspected or any traffic which needs to be
and
inspected, and then you need to put your
this is my stateless
you need to
ICMP
pick
and
your
RDP.
action,
You
whether
saw
you
that
need to
earlier we
pass
were
the
able to
traffic, drop
ping
the
as well
traffic,
as
alert or
RDP
reject
as
it,
well.
right? Then we have
So
rules options as
this
well.
is my
You can
rule.
add
I'm gonna
rule options if
okay,
possible,
click the rule
if needed,
and add it
and you
here.
can add the
Sorry,
rule. So
it
this
was
is
not
how
in
you
place. Click
create
the
your
rule,
standard
and
stateful rules, which we're not going to for this
so I'm
demonstration. We're
gonna
going to
click
use
drop,
domain list. Let's gonna cancel here, and let's have another look
pick your
on this
protocols, so
stateful, another
ICMP
format, that is
and
suricata
RDP.
compatible rule string. So again, the same strict order action order is the rule. Give some name,
RDP and
let's say some
ICMP,
capacity here.
and
I'm gonna show
click
you
on
the options so
save
that you can understand what is the difference
and
between all these three
save.
rule group formats. So here you can
So
define
let's see what
the
happens now.
same. Here you can put
So
your
I'm
suricata
saying
compatible
drop the
rule string
traffic.
here,
So
and
if I
where
open
you,
the
if
command
you're already
prompt,
using this open source network IPS, then you can copy those
so
rules from
let's
there,
ping
those rule strings, and paste it here,
is the
and
IP.
you can create those rules
And you see, we are
quickly.
not able
So
to ping now.
basically,
The ping is
you
not
need
going
not
through.
to
This
learn a new
traffic is being
format
timed
to
out. So guys, you
create
saw
your
how it,
rule
uh,
groups for the
this network
AWS network
firewall worked,
firewall, right? So
right?
I'm going to cancel it.
So that's it for this session. Thanks for watching.
Now,
Thank you.
once it is done, we need to create, or we need to use the second component. If you remember, that was the firewall policies. So these firewall policies will take these reusable rule groups and connect them together. So currently there's no firewall policy. I'm going to create a firewall policy, give it a name. I'm going to call it firewall policy 01. You understand that firewall policy contains rule groups and some policy level behavior settings. Just put a description here. Now the stream exception policy, basically what happens, and how you want network firewall to react when network connections break midstream. So either you want to drop all subsequent traffic, you want to continue processing rules without thinking out what happened from the previous traffic, and you can reject, right? So once reject, it will be a fail close, and a TCP reset packet will be sent to the sender so that they can reinitiate the communication if required. So I'm gonna stick with the default drop action if it is for the stream exception policy. Now what happens for the fragmented packets? So you can also inspect fragmented packets. So you want the same action for all packets, or you want different action for full packets and the fragmented packets, right? So for, if you want to use the same action, the action defined here, either you can pass, drop, or forward to stateful rule groups. I'm going to use the forward to stateful rule group. So once stateless engine inspects the traffic, then it should pass it to the stateful rule group so that it can have the further inspection of the traffic. Now here you will add your stateless and stateful rule which we have created earlier. Click on add stateless rule group. This is my stateless rule group. Click on, selected, add your rule group. Now once it is added, it will now ask to have evaluation order and a default action for stateful. I'm going to go with the action order, add stateful. This is my stateful rule group. Click on add rule groups, and once you've done that, it will start showing what is the capacity which is being consumed by stateless rule group and what is the capacity which is consumed by the stateful rule group. Click on next. Now again the same option, whether you want to use a customer managed key, and if you want to use some policy variables where you want to have you don't want to, you want to override home net variables. So basically the home net is if you are using your AWS network firewall in a centralized architecture where it is part of a different VPC. So the home net is basically the VPC CIDR where your AWS network firewall is present. And if you want that, okay, it should inspect other VPCs as well, you can override this value by putting those IP address ranges here. But this is an option. So, but this is how you can use it, right? Click on next. If you want to add TLS inspection configuration, you can do that. So this is also possible. This basically it will contains your SSL and TLS certificate references and your 5 tuple settings, which your network firewall will use to decrypt traffic going to the firewall you associate with this policy, right? You do that from again, it's an optional thing, but it is required for the production scenarios. Here you can add some firewall policy tags, which is not doing for this demonstration. Once you are okay with the configuration input we have provided, click on create firewall policy. Now this will create a firewall policy for you. We are not done yet. We have created rule groups and we have created the firewall policy. Now you understand from the presentation that we need a firewall to connect all these things together to protect our VPC, right? Before we do that, let's go to the, okay, let's do it first, then we'll come back again, right? So go to firewall. Now we understand we have created fire rule group firewall policy. Now let's, there is the final thing to create. Give it a name. I want to call it firewall demo 01. Give an optional description if you want, and they should define what you are about to inspect. Click on next. Choose your VPC where the firewall you want this endpoint to be, so click on firewall lab VPC. After that, pick your availability zone and then choose your firewall subnet. So I have two subnets. I'm going to keep it in the firewall subnet. Choose an IP address type. I want IP version 4. It can be dual stack as well. It can be IP version 6 as well. So click on IP version 4. Click on next. Now you will have option to delete protection. So it will basically protect the firewall to be deleted accidentally. If it is enabled, your network firewall won't be able to delete the network firewall until it is in use. You can come change the option, then only you'll be able to do it. Similarly, we have subnet change protection. You can protect the firewall against changes to the subnet associations, right? If it is enabled, you cannot change an active firewall subnet association. So if it, let's, in the previous part we make it a part of this subnet, it will stay with this same subnet. Okay. Customer managed key, again this data is encrypted by default with the key which AWS owns. If you want customer key, you can pick here. Click on next. Now either you can create and associate an empty firewall policy if you have not created one, or you can associate an existing firewall policy. I'm going to use an existing one. This is my policy. Click on next. I don't want to add tag now, but it's good idea to add a tag. Click on next. Once you're okay with the inputs which you have provided, click on create firewall. It takes some time before your firewall gets created. So once it is done, we'll be back. Now you can see the firewall is in a ready status. So just walk through. I want you to pay attention here that once it is done, we can also create, or we're gonna create logging part. So now this firewall is in a ready status. Now what we're gonna do, we're gonna create the logging. So click on logging. So we'll collect logs. There are two types of log which firewall can provide you: alert logs and the flow logs. We're gonna use both of them. So you can have both of these logs created. The log destination can be S3, your CloudWatch log group, or the Kinesis data firewalls. I'm gonna use CloudWatch log group. So this is for my alerts. I'm gonna use, I have already created this log groups in the CloudWatch. So FW alert 101 for the alert, and for log I'm going to use FW LG01. So these are the log groups which I have previously created. I'm going to use the same one. So click on save. So now the logging would be saved on to those log groups which we're going to use later on. Now our rule groups firewall policy and the firewall is ready and connected, but it is still won't be able to do any inspection of the traffic. And I hope you understand why, because we have not changed the routing yet, which is the most important part of this demonstration. So please pay very close attention to it, guys. So now what we'll do, we're gonna go to the route table, right? So first we're gonna change the routing. It's gonna taking a bit of time to click on EC2. I want to see whether I'm able to ping the machine or not, because the rule which we have said, it is for the ping as well as for the RDP. So this is my instance. Let me quickly grab its public IP. So you can see we are able to, ping the public IP of the EC2 instance, which is the public IP, right? So it's working. Now let's go back to the VPC again and change the routing part of it. You understand, we are able to do RDP, we are able to do ICMP, and were able to access those websites, right? So click on route tables. Now we have only one route table, and you understand we need route table for our file subnet, and we firewall subnet, and we also need route table for the internet gateway. So let's quickly create couple of route tables. I want to name it IGW, that is internet gateway route table 01. Select the VPC. I'm going to pick the firewall lab VPC, click on create route table. So this is one route table I have already created. Let's go back again and click one more. This time I'm going to call it firewall route table 01. Again the same VPC, click on create. Now let's quickly change the routing. So this is very important. Let's quickly go and change the routing for internet gateway. So currently this route table has got one entry for the local. I'm going to make sure that this route table works with the internet gateway and send the traffic to the firewall subnet. So first I need to change the edge association, right? Click on edit edge association, and I want this internet gateway to be associated with this route table. Click on save changes. Now in the route we need to add something here. Click on edit. It should, rather than staying local, it should go to the gateway load balancer endpoint, that is our firewall endpoint. So it's a VPC endpoint. Pick here and click on save changes. I'm going to save the changes. Click on remove this one, save changes. Now this route table, again I'm repeating myself, I have changed the route for the VPC destination to firewall endpoint, and I have changed the edge association for the internet gateway. Let's go back again, and now we'll go and check the firewall route table, right? So I'm just open this one again. First I'm going to change the subnet association. I will associate it with the firewall subnet. This is my firewall subnet. Click on save, right? And then the route is, you can see there's a one local route. I'm going to edit the routes. I'm going to add the route. Again, any traffic which is going to the internet, it should go to the internet gateway. That's what I'm going to tell, right? And this is my internet gateway. Click on save changes. Guys, remain very careful here. This is very important point. Now the another route table is here, firewall public route table. I'm going to pick this one. This is already associated, and but it was sending traffic to the IGW. I'm going to change the route. If you look at it, this is already associated with my workload public subnet. So I'm going to change the routing here. Now what I'm going to say, this route should not take traffic to the internet gateway. It should send traffic to the firewall subnet so that the traffic can be inspected, right? So go here, load balancer, and this is my firewall endpoint, and save the changes, right? So guys, you can see what changes we have done, right? So